Okay, so welcome back to the tutorial. So in this case, we're gonna see some practical simulation over here for ARP and DNS. Okay, so we're gonna talk about the ARP first. So you can see that there are two different pieces, PC0 and PC1, and there is a server 2 and there is a switch. So these components have already been set up by me, so you don't need to worry about that. We're gonna learn how we can set those up, but we're definitely not gonna learn those right now. So we're just in the primary phase, and since we're in the primary phase, that's why I already set them up for your convenience, and hopefully you'll be able to learn them step by step, and you will have no problem understanding those. Okay, so let's just get back to ARP. Okay, so address resolution protocol, or ARP. We understood that ARP is a protocol by which you can actually get the MAC address of the destination with the help of an IP address. Okay, so what we're going to do here is that it's just a regular task here. Let me just refresh that. I can see that there was a spelling mistake. Okay, so we usually browse thousands of sites every month, right? Usually browse a lot of websites on the internet every day. So just like that, we're going to browse a site called www.test.com from one of these pieces over here, and we're going to learn how the ARP works whenever we want to browse something over the internet. So you can see that this has a very strong resemblance of what we do in our everyday life. Okay, so every day we search www.facebook.com or www.google.com, and we're just gonna do something like that, www.test.com. We're gonna browse their site, and we're gonna learn how ARP works whenever we want to search something over the internet. Okay, so there are two different modes, real-time and simulation, in Cisco Packet Tracer, and we're gonna do our simulation in simulation mode, because if we do the simulation in real-time mode, then we won't be able to understand the steps. So we're gonna do it in simulation mode. Okay, so let's just move into simulation mode, and here, okay, so we have two different pieces. Okay, so let me just give a short intro to the things I have already set up. So I have already set up the IP addresses of those pieces, and yeah, you can see that I've already set them up. I have also set up the server over there with IP addresses and subnet mask and DNS server and everything. So yeah, so I've already set them up. I have also set up some other services using this server. I have set up the HTTP service and the DNS service, etc. So you don't need to think about all of this right now. For the first few labs, I'll do all of them for you, but after that you will be able to learn them one by one. Don't worry about that right now. Okay, so we just want to learn how ARP works in this tutorial. Okay, so what we're gonna do is that we're gonna go to PC0. Okay, PC0, and we're gonna browse using the web browser over here, and we're gonna browse the website called www.test.com. Okay, so just like our normal Firefox or Google Chrome browser, so we just wrote www.test.com, and we're gonna press go, and here you can see whenever we pressed go, you can see that there are two different packets created. One is shown as ARP and the other is shown as DNS. So there are two different packets, and we're gonna see the ARP part first, and then we're gonna see the DNS part. Okay, so let me just tell you some very basic things about what actually happens when we search something. So whenever you post a URL on your Google Chrome browser, like www.facebook.com or something like that, then your browser actually take seeks help from the internet and it tries to contact the local DNS server, which is actually connected to your what can I say, to your IP address. Okay, so let's just say in this case we're browsing from PC0. So whenever I want to browse something from PC0, then this query of mine will actually look for the DNS server which is connected to this PC. You can see whenever I put my mouse over here, you can see that there is a so there is a DNS server which is shown as 192.168.1.10. So whenever I want to browse something, the first thing it does is that it actually looks for that specific address 192.168.1.10. it actually looks for the device which actually has this IP address. So if you can see right here that our server is actually holding this IP address 192.168.1.10. Alright, so whenever I want to browse something from PC0, the query it searches for that specific IP address. It searches over the internet like, oh, where is that IP address, where is that IP address, and then it finds out that it is actually the server's IP address. So it communicates with this server over here. Okay, so in your case it might be different. Whenever you want to search something like www.google.com, then it definitely doesn't automatically connect you to the Google's server. All right, it's not possible. So it connects you to your local DNS server, that server is set up on your ISP site. So it connects you to your local DNS server at first, and then from there it connects to another DNS server, then it connects to another DNS server, and by using this procedure from hop to hop, it gets to to the final server where the actual Google's data is being stored. Alright, so that's how it actually works. Whenever you want to search www.facebook.com, it does not get connected to the Facebook server right away. It connects to the local DNS server, then from that server it sends the query to another server, then to another server, and then to another server. So this is how the whole internet actually works. So there are a lot of theoretical concepts over here, and there are a lot of tutorials about how this procedure actually works or not. So we're not going to talk about a lot about them, but you can definitely learn them by just going over your textbooks or other tutorials in the internet. Okay, so let's just move on over here. So we want to search www.test.com. so the packet is created and it knows that it needs to go to that DNS server address over there, 192.168.1.10. so this address is actually the address of this server, so the packet will go to this address. So we're gonna see this green packet right over there. So there are two packets. This brown one is the DNS packet, and this is the ARP packet. So we want to see the configuration, the functionalities of this ARP packet at first. So let's just see that. So there are three different buttons. One is for going backwards, and this is just autoplay, and this is from going forward. So I'm gonna press this capture forward button over here, and it will show me that the simulation will be done in step by step. Okay, so so you can see that this green packet over here, it just moved from PC0 to PC5. So remember what I said, that whenever an ARP packet is created, there are various fields in that ARP packet. So let's just verify them. Okay, so let me just go into inbound PDO details. Okay, so here you can see that ARP is written here, and this is the overall format of an ARP packet. And you can see that there are several fields right there: source MAC address, source IP address, target MAC address, and target IP address. So this is actually similar to this one, right? So source MAC address, so this MAC address is definitely the MAC address of this PC. Let me just show you. So yeah, you can see the IP address and the MAC address. The MAC address is on the right side of this new hover box. So 00D097223, something like that. Yeah, so that's just the source MAC address, and this is the IP address. This is the IP address of this connection. Okay, let me just show you again. Okay, and the target MAC address is all 0. all zeros because it still doesn't know the MAC address of that specific destination, that specific server. It doesn't know the MAC address of that server, so that's why they're all zeros. And here, okay, and here the IP address, this is the target IP address. It knows that the IP address of this server is 192.168.1.10, but it still doesn't know the MAC address of the server. So you might wonder that if I already know the IP address of that specific server, that specific connection, then why do I need the MAC address? I can directly send my data to that server, right? But the concept is that whenever you think about an IP address usually means the address of a connection. Okay, it doesn't mean the address of a device. Whenever I want to I want to say something device specific, then I need the MAC address or the physical address for that device. So if I only know the IP address, then I only know the address for that specific connection, but I don't know the address for that specific device. So to send a data, I need to know the IP address. I need to know both the IP address and the MAC address. That's why only knowing the IP address is not enough to send a data. Okay, so this is the initial scenario of sending an ARP packet. So let me move on. Okay, so another thing, remember what I said, that whenever I want to send an ARP packet, it is usually a broadcast packet, so it will send the data to all possible destination. Okay, so let me just show you right here. So yeah, right there you can see that the packet actually moved from switch to PC1 and switch to server 0, because from switch it had two possible places to go, PC1 and server 0, so it went into both the places. Okay, but you can see that this PC1 icon over here is constantly showing cross or cancel button, or something like an icon with cancel. Okay, so this is showing that the IP address which was embedded in that ARP packet. Okay, so let me just show you over here again. The IP address which was embedded into this ARP packet, the target IP address, did not match with this PC's IP address. Okay, because this PC's IP address is actually 192.168.1.3, but here the target IP address is 192.168.1.10. so since these did not match, that's why this PC is actually refusing this packet. Okay, but you can see that in this case, the server's IP address is actually 192.168.1.10, which actually matches with this IP address, the target IP address. That's why there is no cross sign over here. Okay, so this is a broadcast packet. The packet was sent to all possible destinations, and now let's see what happens. So since this server's IP address matched with the packet's IP address, so only this server will send a response. This PC1 is refusing the packet and will not send a response. So let me show you. See, the server is only responding the packet. There is no packet going from PC1 because this already refused the packet which was coming from the switch. Okay, so server responded the packet, and you can see, if you want, that here this packet from server to switch, this packet over here, you can see that right there is a target MAC address. So it was not here before. Let me just show you one step before. Right over there, the target MAC address was still 00000 and 0, everything 0, but right over here at this step, when the packet was sent from server to switch, this is a response packet basically. So this packet is not a broadcast packet, it is a unicast packet. Okay, this is a unicast packet. Let me just write it over there. So it is a okay, so this is a unicast packet. Unicast means it goes to only one direction. Okay, so from this server, this packet is going to only one direction, switch, and here you can see that at this packet there is a specific MAC address which is written as target MAC, and this MAC address is actually the MAC address of this servers. Okay, so here you can see the MAC address. Okay, so I just said something wrong. Okay, so this MAC address is actually the MAC address of these pieces, and you can see that the source MAC address over here. Okay, so the source MAC address is actually the MAC address of this server. So initially this field was empty. This was written as all zeros because initially the ARP packet didn't know which MAC address it should get connected to. But since this is a response packet, so this server knows its own MAC address. So that's the source MAC address, and this already knows the target MAC address because it is sending a response, and it knows that where to respond to. Alright, so that's why this target MAC address is actually the MAC address of this PC's MAC address. Okay, so this response actually reaches eventually to that PC, and finally here you can see that this packet has the source MAC address of, okay, so if you can just see it right there, this packet has the source MAC address which resembles the MAC address of these servers, and the target MAC address is the MAC address of this PC. So now there is nothing like all zeros in anywhere in this frame, in this packet. All right, because now the packet already knows the source MAC address, it already knows the destination MAC address, so now it just understands where it should get connected to. Okay, so that's how ARP actually works. So initially we did not know the MAC address. The ARP packet did not know the MAC address. Initially it already only knew the source IP address and the target IP address and the source MAC address. So the target MAC address was completely empty, but whenever there was a response, there was a valid response, then in the response packet you can clearly see that there was absolutely no zero in this packet over here. So all the fields were filled up using valid addresses like source MAC address, source IP, target MAC address, and target IP. All of those were completely filled up using valid addresses. So this is how actually ARP works. So what we did here is that we actually took help of the IP addresses, and we tried to find out the destination MAC addresses, which is actually this one. Okay, so this is the MAC address of this server. So this is the address we are looking for, because we already knew whenever we sent the initial ARP packet, we already knew the source MAC address, which is the MAC address of PC0, but we did not know the MAC address of the server. So when the ARP perfectly worked, then at this step we can see that we are able to know the MAC address of this server, which is written here as the source MAC address. So we took help of the IP addresses, and we found out the MAC address of our intended destination. So this is how ARP works. So that's actually the definition of ARP. That ARP is a protocol by which we can actually find the physical address of the destination with the help of the destination IP address, and we actually did that in our simulation. So that's how ARP works. Next we're gonna learn about DNS.